Hello, my name is Edwin Feng, and I'm from the Liberal Arts and Science Academy in Texas.
Hi, I'm Anjali Kapilavai, and I'm from the Edison Academy Magnet School in New Jersey.
We are pleased to present our NASA's project, titled Forecasting Soil Acidification Risk from Wet Deposition Using Deep Learning. To start, what is wet deposition? Wet deposition, commonly known as acid rain, is a process where gases and particles are removed from the atmosphere and deposited onto the Earth's surface through precipitation. Wet deposition can lead to soil acidification, as pollutants, like those from burning fossil fuels, lead to an increase in the concentration of H+ ions in the soil, decreasing soil pH. Specifically, ammonia deposition leads to nitrification, releasing H+ ions.
Soil acidification weakens roots, reduces seed germination, stunts shoot growth, and lowers plant density. It also harms beneficial microbes and soil fauna, degrading soil structure and increasing erosion risk. Acidic runoff can release toxic aluminum 3+ ions into waterways, threatening aquatic life and food webs.
Although numerical models have been a standard to predict air quality, Jiang et al. Performed case studies using machine learning to predict nitrate deposition fluxes. They found that their simple CNN architecture outperformed the standard numerical model.
Lin et al. Were the first to model ammonium wet deposition using machine learning to our knowledge. They demonstrated weak to moderate predictive ability, pushing us to investigate the use of complex CNN-based models to improve predictions. Our objective was to develop a machine learning model to predict ammonium wet deposition based upon monthly meteorological data and monthly air quality data. We studied Riverside County, California from January 2017 to December 2018. Our input variables were precipitation, maximum and minimum temperature, air quality, and vapor pressure.
In order to retrieve data for input and target variables, we chose the following data sets. For precipitation, vapor pressure, maximum temperature, and minimum temperature, we utilized the DayMet V4 dataset, which provided us with 1 kilometer monthly measurements. For monthly ammonium deposition, we utilized the U.S. Geological Survey data release, which provided 5-kilometer gridded data for the conterminous United States. Finally, for PM2.5 estimated concentrations, we pulled data from the Atmospheric Composition Analysis Group, SAP PM2.5, from Washington University in St. Louis. For data curation, to start, we retrieved data from NetCDF and TIFF files. We sampled to a common resolution of 0.01 degrees by 0.01 degrees, and then clipped data to the county shapefile and converted it to the CSV format. We cropped 6 32 by 32 pixel patches for each covariate and applied dihedral D4 transformations to each patch to expand our dataset. Once the patches were cropped, we stacked covariate raster layers into one multi-band input and paired them with the target patch. Finally, we shuffled our samples and split them into training, validation, and testing sets with a 70-15-15 split.
We chose to repurpose the existing attention-based UNet model architecture for pixel-wise regression. A UNet is a convolutional neural network with symmetric encoder-decoder structure, and this version has skip connections and attention gates. We did not use an activation function because our task is a regression task, not a classification task. Additionally, since our image resolution was 32 by 32, we had a shallower network architecture. Finally, we trained the model using the Huber loss function, a combination of mean squared error and mean absolute error. Our model's loss curve over epochs during training can be seen here. On the test dataset, our model achieved a loss of 1.33, a mean squared error of 9.78, and a mean absolute error of 1.67. When plotting predictions against the ground truth values, the R-squared value we achieved was 0.66. These metrics show that our model outperforms state-of-the-art ammonia deposition model significantly. We cropped our county to a uniform rectangle that can be divided into squares that our model can make predictions on. The predictions were stitched together to make a continuous heat map. Here, you can see the ground truth versus our prediction on independent scales. Here are the same predictions on the same scale. The model predicts ammonium deposition with a very high spatial accuracy. Identifying a suitable model architecture given our data format was not straightforward.
We also had to perform multiple sanity checks to ensure our dataset was valid and usable for training. Additionally, the 5-week time constraint made it difficult to expand more on the project and test other models.
We were able to successfully implement, train, and test an attention UNet model to predict ammonium deposition, which shows a 55.7% increase in R-squared than state-of-the-art models.
Our model produces predictions that can be used in soil acidification mitigation efforts, showing the real-world impact of our work. As a reflection, through this internship, I've learned a lot about the process of research and how to combine knowledge of environmental science with computer science and technology. I also expanded my geospatial analysis skill set, giving me a formal introduction in working with multidimensional data.
Through analyses, I was able to apply my machine learning skills to a real-world problem. I also learned how to effectively communicate my research ideas. This internship was also my first exposure to geoinformatics and the environmental science field.
Thank you to the entire Air Quality Initiative mentorship team for their support and guidance through our research process.
Without Ms. Mitra, Dr. Jiang, Ms. Paudyal, Ms. Mierzwiak, and Dr. C's support, this project would not have been possible.
We enjoyed the internship experience and learned highly applicable skills. We will miss our team so much. Here are the references we used in our presentation.
Thank you all for listening, and please do not hesitate to reach out to us with questions or comments.